these you just need to memorize. Okay, so memorize these two. Now they're on page 64 if you need some more information on that. So if you use direct substitution here, we'd be dividing by 0. Same thing here. The sign of 0 is 0. We'd be dividing by 0, so that's bad. So these are on the semester exam. They're on the, they show up on some AP exams here and there, so make sure you memorize them. Also, you could start a semester exam study sheet where you're keeping track. Instead of having to flip through your whole notebook, if you just put these things on a page, so you get a piece of paper, semester exam, and you write this down on there. And then that puts all that information in one place for you to study. So you can also color code it. So I highlighted semester exam. I'm going to try to remember to highlight in purple anytime I mention the semester exam specifically. So here, the limit of sine x over x equals 1 as x approaches 0. Okay, that's important. Any other number there, you're going to use direct substitution. So you can't just memorize, hey, there's the sine x over x, that equals 1. You have to also have it approaching 0, so be careful about that. Okay, so when you see this trig limit and you notice that when you plug in 0 you get dividing by 0, you know that there's something wrong. So there's probably something you can do to adjust these to make them look like those two that we're going to memorize over there. Okay, so on the first one, I notice that this is the difference of two squares. And so hopefully we realize, okay, if we factor that, we would have 1 minus cosine x times 1 plus cosine x as the difference of two squares. And so we can also split this up a little bit, and we could put, there's 3 times x, so I could put the x over here and the 3 over here. Just times, put the dot in there if you want to, but alright, so this, if we look over here, now we don't want to always have to look over there, so you have to memorize this. The limit as x approaches 0 of 1 minus cosine x over x is 0. So remember, in the properties that we talked about previously, when we're multiplying two things together, we can take the limit of each of those things separately and multiply those together. So now if we do this side, now you might say, well, why are we doing that side? Because we're multiplying by 0, we're done. That's true, but let's see it anyway. So if we plug 0 in here, we have the cosine of 0. The cosine of 0 is 1, and so 1 plus 1 is 2. So we have 0 times 2/3, so that's going to be 0. Okay. And now this is really close to this one. We're approaching 0, but the key is, it is the reciprocal, but since it's equal to 1, the reciprocal of 1 is 1. So that tells us that x over sine of x is also 1 when we take the limit as x approaches 0. So this is really close to that. So you ask yourself, well, what could I do to this to make it so that it fits this pattern? So hopefully, and you can pause that if you can try and think of it yourself, but I need a 5 right here. Well, can I just multiply whatever I want by 5? No, but I can multiply by 5 over 5 because 5 over 5 equals 1. So I'm going to multiply by 5, and then in front I'm going to put 1/5 because that's 5 over 5. That's 1. So we've got 1/5 times this limit. Now these match, 5x and the sine of 5x matches the pattern. That equals 1. So 1/5 times 1 is just 1/5. Alright, last page is over here. Okay, complex fraction. Evaluate the limit if it exists. So as we first start to look at this, if we plug in 2, we would be dividing by 0. That's not good. So when you have a complex fraction, those of you who had us for honors geometry up here at Arborview, we tried to talk to you about clearing the fraction. So a complex fraction is when we have a fraction in another fraction. And the best way to handle that is to clear the fraction. So our common denominator here between x, 2, and 1 is 2x, least common denominator. So we're going to multiply by 2x over 2x. Now, when we multiply, we're going to distribute here. So we're going to have 2x times 1 over x, which is just 2, minus, here the 2's cancel, so we're going to have 2 minus x. So that's our new numerator. That's a lot nicer than what we had before. Now in the denominator, just like rationalizing the numerator, we're not going to multiply that out. Usually multiplying that stuff out is not helpful. So now, hopefully you've seen this in the past, but if not, I'm going to go over it right now, so it's not that big of a deal. These are opposite factors. Opposite factors. And you can see that it's reversed. So what you want to do there is you want to factor out a negative 1. If you factor out a negative 1 out of there, then you can flip that over. So that would be negative x minus 2. So if you think about that, that would give you negative x plus 2, which is equivalent to that. Now, those are going to reduce, cancel. So now we have the limit of negative 1 over 2x as x approaches 2. So if you plug 2 in there, 2 times 2 is 4. That's going to be 1/4. Now be careful. Notice how we have positive 1/4 and negative 1/4. So we do not want to make careless mistakes like that. This is correct, but I'm just saying. I have seen students in the past just circle that because they just don't notice. So be careful. Okay. Every once in a while you'll see me highlight stuff in orange. That just means that I want to change the notes. So we don't really need this right here. I took something else out and I didn't take that out. So you don't need to highlight it in orange. You could just cross it off. Or what it was I was asking what is another way to think about tangent, and it's sine over cosine. So, but we don't need that right now. All right, wrapping this up, last two, two examples and an idea. The squeeze theorem, some people call it the sandwich theorem. So, let's look at a situation right here. So we have a function h, and h is less than or equal to f and g. So it's the lowest function. So let's just make it simple. So there's h. That's the least of the three. And then we have g is the most. So g is always the most, or equal to. So let's just say g is up here. Something like that. Okay? And we have a third function that is always more or less than, more or equal to h, but always less than or equal to g. So that means it's somewhere in between there, or it can be equal. So let's say it's going down like that. Okay. So if at c the limit of h and the limit of g are both L, so this is telling us that f is always in between these other two functions. But it's telling us that the bottom and the top have the same limit at c. That must mean that f also has that same limit, since f is always squeezed or sandwiched in between the top blue one and the bottom red one. So hopefully that's fairly clear. Now, I believe I saw that on an AP test once or twice in the last decade. So that should be something that we maybe consider a little bit, but not too stressed out about. But I don't think it's that bad. So I don't want to get out the graphing calculator on this. I'm just going to tell you real fast. We're almost done here. So let's just think about it. We don't need a graphing calculator to graph x squared and x. So x squared is going to basically look like this, and negative x squared is basically going to look like this. Now, if you graph this function here, which you can do on your calculator if you're looking for something to do, but I imagine you're all pretty busy, so it kind of looks like that. So you can see though that it's telling us that it doesn't tell us, but we can see